Hello, everyone. OT cybersecurity being today's topic. So OT cybersecurity as easy as 1, 2, 3, or as I like to call it, OT cybersecurity, world's easiest gig. But let's start with the definitions. First, OT being operational technology, IT being information technology. And I sometimes get to hear that OT cybersecurity, it's complex, it's difficult, it's hard. Where to start, what to do. And if this is the perception, cool. I will try to change that today in around 30 minutes, showing that it's quite easy. First, a bit about me. My name is Mattias Karpidler. I am Swedish. I live in Denmark. I work for ABB, and I joined ABB back in 2012, starting as a system engineer, installation, upgrades, maintenance, industrial control system, DCS system. Back then, it wasn't always referred to as OT. Perhaps industrial IT was the common term used. Comes 2017, I shift my focus entirely and work with cybersecurity in OT. And since beginning of 2022, my role is the cybersecurity solutions consultant for ABB Process Industry Division, the division that caters towards customer in pulp and paper, for example. And before joining ABB, I worked as an IT consultant for around 10 years. So back to the topic of today. What do I mean OT cybersecurity easy? Let me explain. I like to compare it some to IT, and IT nowadays being complex. Users have multiple devices, smartphone, laptops. They are accessing documents from their home office, from airports, from coffee shop, or from the office itself, collaborating in these documents. They should be available all the time from any device, anywhere. OT environments, not exactly as complex and dynamic in that sense. We have a usually very limited number of devices in these environments. We don't have users connecting their own laptop to the network, trying to access a shared document. Hopefully not. For me, these environments are usually centered around industrial control system or multiple industrial control systems. These systems being quite deterministic in that sense, what they are supposed to do on a day-to-day basis. We can baseline them pretty easy, therefore they are easy to monitor. And my favorite point being that current cybersecurity in and around these systems and these OT environments are, to be frank, quite low. So therefore they are easy to systematically improve, which is nice. Not trying to bring the good mood down or spirits down, but some numbers associated with the state of cyber. I will not go into all of these in details, but I think it's quite fascinating that cybercrime is the single biggest transfer of wealth nowadays. It has well surpassed the global drug trade. And I think one of the looming threat that most organizations are very well aware of is the threat of ransomware. Ransomware being very destructive pieces of malicious code that is designed to encrypt the entire system, lock them down, present a message on screen, pay the ransom, or else your system is locked indefinitely. Recommendation being, of course, not to pay the ransom, restore from backup. So please make sure that good and functioning backups are very well available, easy to access, safe, stored offline as well. Anyway, another key takeaway here is that it takes a lot of time to notice that there is a breach and something is in the environment. I think more so in OT environments. To be honest, the visibility is quite low, but I will come to that, back to that in a bit on later slides. Some examples of what the cost might be associated with not addressing the cybersecurity within these environments. There are in different parts of the world coming rules and legislations, directives that If you're a producing company, you have to show and you have to improve your cybersecurity systematically. It might otherwise lead to fines or sanctions from regulating bodies. Might also be a possibility of releasing hazardous materials into the surrounding environments due to a cybersecurity incident. What we definitely want to avoid is that workers risk their health or their life even because of a cybersecurity incident. That we want to avoid at all cost. But what I think most is connecting these two is that we know the potential of a cybersecurity incident causing production outage or production loss is very, very costly. We count it in perhaps minutes or hours or days, and it can be very expensive, even by the minute. So why is it like it is? If we again compare a bit to IT, it is quite the situation there was in IT years back when we had these point solutions, multiple security solutions like anti-malware or antivirus, backup, patching solutions. They are siloed in that sense. They have no integrations. They all come with their own management interface or management dashboard. Someone has to manually log into these dashboards and see the status of that particular solution. It can be quite complicated. It can be quite time consuming. It can be honestly considered as a hassle. And to be even more honest, if that status is not checked up on a daily or weekly or monthly basis, well, nothing actually happens. The world keeps spinning. But with the example for a backup, it can be quite a rude awakening to notice when you need a backup that, hey, my backup hasn't worked for days or weeks or months, and now suddenly you need it. But we need a new approach for this in the modern world and the current state of OT environments, which I will come back to in a bit on a later slide. ABB, what can we do to help with end-to-end industrial cybersecurity? The cybersecurity pie. We have 3 parts. Assess being the first part. This is usually where it starts off. We have to figure out what is the current status or the current cybersecurity posture of the OT environment. We need to know where to focus our efforts. So we assess the situations. We make a gap assessment. After that, we have the technology part, implementation of tested, validated solutions for these OT environments. We know that these environments can be quite sensitive. Production is always number one. We have to be able to install them in the most non-intrusive way as possible. And then we have the services part. Nowadays, we know that everything has to be patched, updated, kept up to date. Network switches, hypervisors, Windows machine, etc., etc. Everything has to be updated regularly in order to keep up with the current threats, vulnerabilities. And then the wheel keeps spinning. We perhaps wants to reassess the situation, see where we are, close the gap, so we start over with an assessment, etc., etc. The wheels keep turning. And this is probably one of my favorite slides, the risk reduction roadmap, the industrial cybersecurity journey. This is a journey that we know that a lot of companies, producing companies are on. The goal here is to take these necessary steps or implement this solution to lower the risk of a cybersecurity incident happening. I will not go into detail of all these solutions or points, but starting from the left, as mentioned, the assess phase first, call it the cybersecurity assessment, cybersecurity fingerprint risk assessment. Goal here is to find out the current cybersecurity posture. Then we have the planning phase. We need to know where to focus our efforts the best. With the current digitalization going on today, we know the importance of network segmentation, proper network segmentation. This is where we have the reference architecture. Then we have the implementation phase where we have the basic cybersecurity controls being antivirus, security updates, backup, system hardening. Disabling to antivirus or anti-malware, application allow listing, meaning that we create a list of all allowed applications to execute. Anything outside of this list is automatically blocked. Creates a bit more overhead as to we have to plan when we install a new application. We have to make sure that it is added to the allow list. And then we have the asset inventory part. Every cybersecurity framework talks about the necessity of having an up-to-date asset inventory. What we don't know we have on our network, we cannot protect. Then we have the maintain part phase. Maintain part, the ongoing maintenance, as mentioned, we have to patch everything and everything regularly, keep doing so year over year. We have to update us humans. We need training on how to behave and what we are supposed to do, not to do with regards to cybersecurity, OT cybersecurity. And then we have the visibility part. We have the event monitoring, we have network monitoring. Event monitoring gathers all the information from event logs. Network monitoring eavesdrop on the network. We send all of this information to the Security Operations Center, the SOC, where we have someone looking at the screen 24/7, reacting to alarms, alerts, doing incident response, seeing lateral movement, see something that is out of the ordinary, movement between IT and OT, to be able to do incident response in time and act before something bad happens. So, ABB reference architecture. Digitalization today being a strong driver. ABB's reference architecture is a document, a blueprint for a segmented network approach. It bears resemblance to the Purdue model. We have the field devices on level 0. Level 1, we have the PLCs or controllers. Level 2, HMI, industrial control system level. Level 4 being IT. And in between IT and OT, we have what's usually called DMZ, the demilitarized zone. In ABB's world is divided in operations management to the left and system management to the right. Operations management being historians, MES systems, meaning we have system that gathers data from the OT environment, from the DCS, from the industrial control system. It makes the data available to the IT level. It might even push data back into the DCS level, level 2. And on the right-hand side of the DMZ, we have the system management, so supporting functions for the DCS, remote access, secure remote access, security updates, anti-malware, backup, etc., etc. But with today's digitalization that is going on, we know the importance of having this safe, secure buffer between IT and OT, where we place these servers, where we place these systems. We place them in the DMZ. We make sure that the rules going through the north and the south firewalls from the DMZ are kept to a bare minimum, as to not having unnecessary vectors going into these highly critical environments, the OT. I have had the good fortune to be visiting customer sites in different verticals all over the world. I have connected to even more customer environments using secure remote access. So these are my presumptions. I put all this experience and aggregated experience also from colleagues and peers, and I put them together, and these are my presumptions of what these environments look like as guests before even seeing them in practice and trying to know where to address. First of all, the current situation is usually not entirely known. We might have system documentation, network architecture drawings, etc., etc. But these systems have long life cycles. They tend to live for a long time. So this documentation does not reflect the truth, what is actually out there. Basic cybersecurity control being patching, backup, system hardening, etc. They are perhaps implemented, but they are not perhaps implemented as best practiced, or they are not performed as well as one would wish. For example, we might not have daily updates for signature files for antivirus. We might not have the backups done as regularly as we would. And if we do the backups as regularly as we wish, well, it's time to try to test them and see that we can restore them, that they actually work. Segmentation, as mentioned, the digitalization is a big driver today. Segmentation is usually not exactly up to par how we would like to have it today, with the safe and secure buffer being the DMZ. And then the final point is, in these environments, the visibility is not on the level that we would like. To be quite frank, we are usually quite blind in these environments, and does not see everything that we would like. So where to start? How to address the problem? As mentioned, usually a good idea when this current cybersecurity posture is not entirely known, start with an assessment. If we can help you with this, we gather data in a non-intrusive way. We have a look at the documents available, the system documentation, the network structure, etc., etc. We create a snapshot of the asset environment in the asset inventory in the environment, the importance of having an up-to-date asset inventory. We need to know what's on the network. We do a gap analysis. We do an analysis of what we think the network should look like, or we would like it to look like. And the most important part, we try to find the crown jewels, the most important assets that needs protection. We need to prioritize our effort, our time, money, and available resources on protecting those crown jewels, those most important assets, starting with them first and then moving on to the other one. We cannot give everything the premium protection right away. We need to focus. This is also usually presented in a phased plan, meaning that we have, first of all, the quick wins, things we can do right away. Secondly, the medium wins, we might have to wait for a maintenance window to do something. And then finally, the long-term wins. We might have to plan it according to budget cycles. Perhaps we want to increase visibility in these environments, but we have to do the criticals and the medium terms first, budgetary reasons, etc., etc. And this is an example of what such an assessment report might look like, part of it at least. The risk registry, what is found in the environment, are there any mitigating things in place, what is the overall risk associated with what has been found, and what is the likelihood that something is actually exploited or happening. Just as an example. Okay, back to patching. This is something that we know we have to do. Can we really patch a DCS system or an industrial control system? Well, yes, of course. They can be based on Windows machine, and we know how to patch a Windows machine. Everyone with a Windows machine at home knows how to patch it, but how to do it in practice, I will come back to on a later slide. But in order to make OT cybersecurity easier, ABB has also developed what we can call a package. I will not go into detail, but start with Protect Essential. This is what we would think the minimum bare bones essential package is for OT cybersecurity. Cybersecurity workplace, starting with that as a fundamental. I will come to that in the next couple of slides. Secure patching. We know the importance of patching. Everything, hypervisors, network switches, etc., etc. Everything needs patches. Windows being one of those things that we know is in need of patching on a regular basis, monthly basis. Malware protection, new signature files for antivirus is released daily. Backup, we know the importance of having a backup ransomware. Again, system hardening, that is keeping the system vectors open to a minimum, meaning we close the local firewall as hard as we can. We remove everything that we do not use. And then we have secure remote access. COVID struck. We all know the importance of having secure remote access to this system to be able to do proper maintenance. Anyway, cybersecurity workplace. This is an on-prem solution, web user interface, a single pane of glass containing all the basic cybersecurity controls, meaning we have information about backups, we have information about security updates, we have information about the antivirus. We can see from this screen that everything is okay. We can create reports. We can compare data from date of 26th of September to the 29th of September, what happened in between these two deltas. But what I like the most is that we actually have the possibility to do tasks from here. For example, patching. We don't have to have local admin rights to the operator workstation. We can give someone access to this web user interface. That user can log on here and actually perform patching of that operator workstation. Well, of course, you're going to have to pick up the phone and call the operator and say, hey, I am going to patch your system. But you can do it from here just by a simple click. This system can connect to virtually any Windows machine. You just install a small, non-intrusive, very lightweight agent. If there is an ABB DCS system, for example, 800XA, you get pinpoint accuracy with regards to the services. And in ABB DCS world, we have redundant nodes. So we have two servers being redundant pair. So if one of them is restarted, you rely on the other one. And if you try to patch them both at once, this dashboard will present a warning. Hey, you're about to lose data. You're about to restart the redundant node. Are you aware of this? So you get the help you need. You don't have to be a cybersecurity or DCS expert to patch using this dashboard. Very, very handy. You do everything from this place. And there's a lot of talk about IT, OT convergence, collaboration. We know the importance of collaborations to be able to keep up with the threat actors with regards to cybersecurity. It's a collaborative effort. We need to help each other out. Are there any difference between IT and OT? Of course, yes, they are. I think there are quite big differences in skill sets with perhaps coming back to normal production in OT as opposed to in IT. You might have to be able to open an engineering tool, change some parameters and download that to a PLC or a controller. You don't necessarily want to reboot or restart machines in the OT environment. But what I say here, the first step is get IT and OT to talk to each other. Don't have them be siloed, get them together, collaborate. And then as an explanation to the dirty hand on the screen, that is actually my hand from working in this OT environment. There was a comment from a friend that I know that, hey, aren't you working with computers? Yes, I do. I work with computers in these wonderful environments where you get to have high visibility clothes and a hard hat and steel toe shoes. So quite nice. I like it. As making it easier to choose the correct maintain package to going back to the protect essentials. Everything needs maintenance to make it easy. There's an accompanying package called maintain essential that can be paired together with protect essentials. Just choose how often you want your system to be patched, monthly or at least quarterly. Let ABB help you and take care of it. So I'm going to fast forward through these animated slides. ABB's approach to cybersecurity. I will now come into solutions with regards to visibility. So we have partners for event monitoring and we have partners for network monitoring. And just to briefly describe what event monitoring is, we collect event logs from Windows machine, firewall devices, network devices, anything on the network. We collect the event logs, even from the DCS itself. We send that to a centralized database or what's usually called a SIEM solution, Security Information and Event Management System, SIEM, where we aggregate all the data. We want to see what's going on from an event point of view. The other monitoring solution being network monitoring. That is basically we are eavesdropping on the network. Network monitoring solution specifically for OT environments I'm talking about now. All the devices on the network communicate with each other. The network monitoring solution eavesdrop on that, see everything that is going on, baselining what is the communication looking from day to day. When everything is known, we can react to everything out of the ordinary, a news device being connected, etc., etc. We want to monitor, of course, for external actors being in our networks, but we also want to monitor for internal actors. Now, they might not be malicious in intent, but we see perhaps that they are doing something, mistakes perhaps. Even I do mistakes sometimes, but we have those visible in our environments. And by seeing these things, we can take actions against them or towards them, trying to figure out what is going on. Network monitoring, ABB has partners in this field. We have Forescout and Nozomi as an example. What they can be used for, they are keeping an always up-to-date asset inventory by listening to the traffic on the network. They create a network map, which machine or which node are talking to which node. So we see everything is happening. They can be used for a lot more, but these was just some of the examples today. Then we have the event monitoring, or the SIEM, as mentioned. ABB has a partner called IBM. In that sense, so we can provide you as a customer even with a SIEM solution. But what ABB has done is developing what we call use cases. And use cases, there are specific scenarios in these environments that we are looking for. For example, in IT, restarting a machine, that's often the first troubleshooting step. In OT environments, restarts are more rarely happening. Therefore, we are looking for restarts and we are triggering a use case or an alert in that case. Now it might be completely normal, but this is something to investigate. Another example is someone is not succeeding in logging into an engineering station 5 times in a row. When they eventually succeed on the 6th time, they immediately start the engineering tool and download to a PLC. This can also be perfectly normal after a vacation, for example, but this is also something that triggers an alert that, hey, this is out of the ordinary. Someone might be trying to brute force a password and succeeding, or guessing passwords. So this raises an alert and, hey, investigate, please. And the accompanying thing to those use cases or a runbook, which is a step-by-step response guide on how going back to normal production. For example, it can be that we have to open said engineering tool, change a parameter and download to a PLC. Everything is described in that runbook. At the moment, there are more than 70 use cases developed and more will be added as we move forward. If we go back to the risk reduction roadmap, the things I have talked about, addressing what the situation of these environments are. And now, with these things that we have covered, the risk is being reduced. Thank you for your time today. This is where I end the presentation.